Hello student, I'm Mr. Leung. So in this video, I'm going to talk about the chapter 1 reading to learn, and the topic is the discovery of virus. So before I talk about the paragraph, so I would like to talk about the disease first. So the disease we are going to talk about is the tobacco mosaic disease. So in this diagram, you can see the symptoms of the this disease. So what we can see is the mosaic pattern of the light or dark green coloration on the leaves. So you can see that the leaves on the right hand side is the severe case, and in the middle one, these two leaves, actually you can see the mosaic pattern. The pattern is a bit pale green, okay, light green, and then if the case become worse, so it will become dark green pattern. So that's the disease. And in the past, the biologists, they would like to find out what is the cause of this disease, okay, and also they proposed that there may be some bacteria to cause this disease, and then that's why they are going to do some experiment, to do some investigation to confirm that. So that's why before I talk about the experiment, I would like to talk about actually the nature of the science is a process of ongoing inquiries. So in this paragraph, okay, in these two paragraphs, you will know that we did not only do one experiment, but also a lot of experiment. We repeat it, okay, and also we may change different methods to undergo the experiment. That's one way. That's the nature of science. And also, scientific knowledge is based on and or derived from observations of the natural world. So that's why we observe the leaves, okay, and then we find out that there may be some disease in the plant, and then we would like to find out the cause of the disease. And after we find the cause of this disease, we can find any method to prevent this disease to occur. So that's the nature of science, okay? How can we construct the knowledge, and also how can we have a process of ongoing inquiries. Today we have one method to do the investigation. Maybe tomorrow we shall repeat it again or use a new method to do it, okay? Keep asking questions. That's the nature of science, okay? So that's why we go back to the paragraph. So after they would like to do the experiment, to do the investigation about this disease, they find a diseased plant, and then they extract, okay, extract something, okay, from the plant. They have the extract, and then they make the extract and pass it through a filter that could block the bacteria. So that means in the filtrate, okay, it doesn't contain any bacteria, because the bacteria, they should be filtered away, right? Okay, and then we spray the filtrate to the healthy plant. So technically, if the disease is caused by the bacteria, so somehow if the filtrate, it doesn't contain any bacteria, it will not infect the healthy plant, right? But to their surprise, the healthy plant got the disease. So that's why they have some hypothesis, okay? They suggested that the disease might not be caused by the bacteria, but the chemicals secreted by the bacteria, okay? So that's why at this point I call it the toxin, okay? The toxin produced by the bacteria to cause this disease, okay? That's the first hypothesis. And the second hypothesis is that, okay, so there may be some organisms which are much smaller than the bacteria. So that's why they may not be blocked, they may not be filtered away by the filter, okay? So that's why some other organism may cause this disease, okay? So that's the two hypotheses, okay, we are going to talk about. And then for the next paragraph, and also with the diagram, actually before I talk about the paragraph, I would like to mention that by using the diagram, okay, maybe you draw something, okay, you visualize, okay, the procedures by drawing diagrams or flow chart is a good way, okay, for us to understand the question and also do the revision. So that's why when you are doing revision or when you are doing questions, once you need to deal with a long paragraph, okay, you can try this method, okay, to visualize what you read, okay. Maybe make a flow chart, make a logical flow chart to make it step by step. A, and then with an arrow to B, with an arrow to C, okay, something like this. So visualize, okay, what you read, okay, can give you a better understanding, okay, of the paragraph. So that's why we go back to the paragraph. So other scientists, okay, they undergo the experiment again, okay. So as what we say before, we have the deceased plant, and then we pick a leaf, and then we try to make some extract, and then we filter the extract, try to remove the bacteria, and then spray the filtrate to the healthy plant, okay. And technically all the plant, okay, they got the disease. So that's what we call the newly infected plant, okay. And we have a number, okay, plant 1. And then for this newly infected plant 1, okay, we also obtain the extract and then filter the extract and then spray the filtrate on another healthy plant, okay. So that's why we have the similar procedures here, okay. We extract it, okay, and then we filter it, and then we spray it on the healthy plant. So remember that actually up to this point, okay, we filter the extract from the deceased plant, okay. So at this point, all the bacteria, or maybe we can say that most bacteria, or just the bacteria, they are filtered away, they are removed. So that's why for the newly infected plant 1 or the other healthy plant, okay, even they got the disease, okay, they may only have the toxin inside the plant cells, right, inside the plant. So that's why. And then we have the newly infected plant 2, and then we repeat the procedure for many times. So that means we shall have newly infected plant 3, 4, 5, 6, 7, 8, 9, 10, whatever, okay. So finally we find that the healthy plant, they got the disease in all cases. So that means for the 2, 3, 4, 5, 6, 7, 8, they all got the disease. So that's why the scientists, they concluded that the disease was not caused by the chemicals secreted by the bacteria, okay, or what I say, that's the toxin. The disease is not caused by the toxin, and then I shall explain it later on in question 2. And then finally they found out that the disease is caused by the virus, okay, and the tobacco mosaic virus, that's the first virus that we can crystallize it and discover it, okay. So for the virus, why is it so special, okay, is that because the virus, they are much smaller than the bacteria. So that's why they will not be filtered away by the filter. So that's why they will still exist in a filtrate. And that's why we spray the filtrate on the healthy plant. The virus, they will infect the healthy plant finally, okay. So that's the whole story, okay, for these 2 paragraphs. And then we go back to the questions. For question 1, that's a bit easy, because what were the 2 hypotheses proposed to explain the cause of the tobacco mosaic disease, okay. So actually you can find in the paragraph, okay, the disease is caused by the certain chemical secreted by something, or the disease is caused by certain organism. That means finally we know that that's the virus, okay, which are bigger or smaller than the bacteria, okay. So I think it's very easy, because you can just find the information from the paragraph, okay. So for question 2, I need to spend much longer time to explain it, because it's very important. Why did the scientists, they concluded that the disease was not caused by the chemicals secreted by the bacteria? That means what I so-called, that's the toxin, okay. The disease was not caused by the toxin secreted by the bacteria, okay. As what I say, actually the bacteria, they were removed, okay, at this stage. So that means in the newly infected plant 1, plant 2, plant 3, plant 4, plant 5, okay, they only contain the filtrate, okay, they only make contact with the toxin, right, okay, only the toxin will infect the plant. And actually from plant 1, plant 2, plant 3, plant 4, okay, so somehow the toxin, they should become less and less because they're just consumed or used, okay, to infect the plant. But what we find is that the extract of the newly infected plant was still infectious, even the procedure was repeated for many times. And this shows that the agent causing the disease was not diluted. That means the number actually will it seems to be the same, okay. The toxin is still a bit concentrated, right, okay. So that's why they can still able to infect the plant. So that's why this would not happen if the agent was a chemical. So finally, as what we found is that the disease is caused by the virus. And just like the case of influenza, okay, and we have the influenza virus get into our body and then we got infected. So the concept is that if we keep coughing or sneezing, okay, to our friends, so we may transmit the disease to our friends. But before they really get infected and develop the symptoms, if the virus, the number of the virus is so small, so somehow they may not be really get infected, okay, or the symptoms may not be developed, right? So that's why the number of the virus, the amount of the virus must be large enough, sufficient enough to infect us. So that's why the virus, they need to multiply themselves, okay, to increase the number in order to infect us. So that's what I want to say in question 3. Question 3 is asking what characteristic of organism can be concluded, okay, based on the result. So that's why after that we know that the disease is caused by the virus, and we see that if we extract the virus from the diseased plant and then we try to filter it, but we cannot do so, okay. So that's why the virus will be sprayed on the healthy plant and infect the plant. And as what I said before, is the virus amount is not large enough, is not sufficient enough, it cannot infect the plant, okay. It will not make the plant become diseased, okay. So that's why the virus, they need to multiply themselves, okay. So that's why I give you all the 7 characteristics of the living organism, and then please pick up the correct answer for me, okay. So I think you can easily pick up the answer, okay. So that's for the question part. And after this question, I would like to recall the concept of hypothesis in the scientific investigation. In this part, I'm going to talk about hypothesis. So before I go in details, so I would like to recall the definitions of hypothesis first. Hypothesis is the proposed explanation based on the observation. So that's why after we have we make an observation on a biological phenomenon, okay, and then we try to make an explanation to explain something, or what is the reason behind that, okay, what is the relationship between something and something, okay. So that's the hypothesis. But one thing many students, they may get confused is that when we are doing the scientific investigation, okay, especially for the SBA, so when we should have a hypothesis, or when we do not have to make a hypothesis when we are doing the scientific investigation. To be or not to be, that's the question. Okay, so that's why in this slide I would like to explain it in details. Okay, and then I will use the two investigation list, okay, the list 1 and list 2, okay, and we shall have a parallel comparison, okay, and then later on you will know in which type of investigation, scientific investigation, we should have a hypothesis, and in which type of investigation actually is not that necessary to make a hypothesis. Okay, so for the first pair is that on the left hand side, I would like to investigate how does the AIDS spread among the population. Okay, and the focus is how, the mechanism behind that. Okay, and then for the right hand side, that's the what are the signs and the symptoms of AIDS. So the focus is what. And the second pair is that what is the relationship between brushing teeth and the chance of suffering from tooth decay. So the focus is the relationship between two factors, okay, brushing teeth and the chance of suffering from tooth decay. And for on the right hand side, the investigation is how many teeth does an adult have. We are also investigating the teeth, but actually the focus is just talking about how many do we have. So the third pair is that on the left hand side, why do the migratory bird fly to a particular region? Why do they fly to Hong Kong? Why do they fly to somewhere? Okay, or why do they fly to my pole? Something like this. And on the right hand side is that where do they fly to? Or they fly to Hong Kong, or they fly to Singapore, or they fly to Thailand, something like this. Okay, where do they fly to? So the focus is where. And for the fourth pair is that why do the enzymes lose catalytic function at 100 degrees Celsius? And actually what we are going to investigate, that's the reason behind. And on the right hand side is that what is the enzymatic reaction rate at 100 degrees Celsius. So that means we have an enzyme, and then we put it and with the substrate at 100 degrees Celsius, and then we investigate the reaction rate at 100 degrees Celsius. So by reading these two lists, I think that you start having a sense of these two type of experiment. The left hand side, okay, the left hand side, actually that's the analytical investigation. We try to explain something, okay, explain how they are spread. What is the relationship between A and B? Why, okay, the reason behind, okay. So that's why we are going to explain something. But on the right hand side, what, how many, where, what actually is a disruptive investigation. So we are just going to describe the biological phenomenon being studied. So that's why actually they do not answer the questions of how, when, why, or the relationship between something. Okay, so actually they just tell me the answer. How many teeth does an adult have? Do you really need to make a hypothesis or of the number of the teeth? Oh, I proposed that we have 23 teeth, and then we count it. No, if you really want to know the number, we just count it. Okay, or 1 2 3 4 5 6 28. Okay, 28 is the answer. 32 is the answer. Okay, we just count it, and then we know where do they fly to, or where we set up a GPS, and then we shall know it, or fly to Hong Kong, fly to Thailand, okay, something like this. We know it already. Okay, we do not really need to make a hypothesis. But on the left hand side, actually this investigation, okay, we can make some hypothesis. For example, the relationship between brushing teeth and the chance of suffering from tooth decay. So some people may propose that No, there is no relationship between them. Okay, no matter you brush your teeth or not, you will or you will not suffer from tooth decay. But some people they may think that no, I propose that if we do not brush our teeth regularly, so we may have a high chance to have tooth decay. So who is correct? The method is very simple. Do the experiment. Okay, we do the investigation and then we shall know which hypothesis is correct, right? Okay, and why do the migratory birds they fly to a particular region? Why do they fly to Hong Kong? Some people they may think that it's about the weather, it's winter, okay, so they need to fly to somewhere a bit warmer, right? But some people they may have another proposal. They propose that because they want to look for more food, okay, or because they just would like to escape from the predator, something like this, okay. So we have different hypotheses, okay, the proposed explanations, and then we try to check it. So that's why we do the experiment, we do the investigation. So that's why on the left hand side for the analytical investigations we need the hypothesis, but for the descriptive investigations we do not need the hypothesis, because we are just looking for the fact or what are, how many, something like this, okay. We do not need to make any hypothesis, okay. So that's why I hope that by using these parallel comparisons, okay, so you can understand more, you can realize that when do we need a hypothesis, okay, and when do we not need to make a hypothesis, okay. So if you understand it, so you can answer this question for me. So for example, so what if you are going to perform a food test in order to determine which types of food substance in the unknown food sample? So actually in this investigation, do we need to make any hypothesis? If so, tell me the reason. If we do not, also tell me the reason, okay. So leave your answer below. If you can get it correct, I will give you a prize. So also if you have any questions, you can also leave it below. I will answer you as soon as possible. See you next time. Bye bye.